Okay, let's look at the complex plane and polar form. All right, so let's look at the complex plane. Means we're going to start graphing these complex numbers. All right, and remember, a complex number is a real part times an imaginary part. I said times, it was plus or minus whichever one. Imaginary, right? Times I. All right, well, let's look real fast on how do you get an I. All right, it's not imaginary in any sense of the word. What complex numbers are used for? It's like a mapping system, right? They're coordinates. It tells you what direction to go. So let's say that I have this right here. I just go out a whole distance of 1. All right. Well, if I wanted to go in the opposite direction, what would I have to multiply this by? A negative, right? So if I wanted to go in the opposite direction, that would be a negative 1, right? Just like here are. So I step forward for positives, I would step backward for negative. Well, what we needed, or what they needed, I guess, is a way to get from 0 to 90, right? This axis. How do you tell people you're going up and down? Well, someone a long time ago came with the idea, if I multiply anything by I, it means it rotates it 90 degrees. So if I multiply 1 by I get I. So you'll see I means I go up. Actually, multiplying by I means I just rotate it 90 degrees. Well, I want to rotate this again. So what do I have to multiply I by to get it to come down here? An I. So that's why I get I squared. Down here would be I cubed. Rotate again. I to the 4th. All right, and now you'll see by doing the positive radius and negative radius, right? So to flip something, I just have to multiply it by -1. I have this term right here. I know that I squared equals -1. Well, how would you solve for I? I would take the square root of both sides. So that's how I get I equals -1. Right? It has nothing to do with imaginary anything. Right? It's not a fictitious world. It's simply a mapping coordinate system. All right? So imaginary numbers are just maps. That's all. It just means that if I multiply by I rotate it 90 degrees. Or in this case, my system, which I just worked out, right? We also learned from 9(5), right, that I cubed is -I, which makes sense, right? If I want to go up for an I, the opposite direction would be a negative, right? Step backwards, -I. Okay, so it's just a mapping system. Well, with that in mind, all right, we'll get back to absolute value. Here it's written down now. You'll notice what used to be the x is now the real number, right? Just like here, +1, -1, those are real numbers. And my y-axes now are the i's, right? So this is a positive I, this will be a negative I, right? So this will be positive reals, negative reals. Positive I, negative I. All right? And now all we're doing with this absolute value, right? Absolute value is simply, as its definition, is a distance from 0 to wherever you're going to go. Right? The absolute value from distance to wherever you're going to go. Right? From 0 to wherever you are on the axes. So my absolute value is this z, going from 0 to the top of my point. Right? Well, if I want to find the distance, I had to go a real value, I had to go an imaginary value, right? An a b, because b is positive. Well, how would I get that? It's Pythagorean theorem. So that's how I get the distance z, the hypotenuse. It's Pythagorean theorem. All right? Okay, let's see how we graph some of these. What I'm going to do is graph these two. All right, well, piece of cake. Let's draw my coordinate system. All right. These are my reals. These are my imaginaries. Oops. You can write real with a double back R. Okay, it doesn't have to be that cool script one you saw before. So the real this way, the imaginary this way. Well, I want to go 4 reals, 4 positive reals. So go 4. I want to go 3 imaginaries, right? The imaginary is in the up direction. 1, 2, 3. Put a dot. That's 4 plus 3i. All right? What if I just wanted to go 3i? Well, I'm at 0, 0. I don't have any real distance to go. I just have up 3. You know what? Let's make this a negative. Let's say I want to go -3i. So instead of going up 3 for positive, I'll just go down 3. Put a dot right there. All right, so that says go down 3, don't move any left and right. All right, so it's simply a coordinate system. That's all imaginary numbers are. Okay, our next piece, polar form. Right? Obviously, you know, it's a whole polar chapter. We need polar form of a complex number. Well, it's going to be the same thing. My real now, right, times my imaginary with r's and thetas. All right? So if you notice, if I went back to get the polar or the rectangular form, if I distribute through by the r, all right, r cosine is just x, r sine is just y. So here I have the real part and the imaginary part in terms of x's and y's. Right, my a's and b's before were pretty much just x's and y's. All right, so here would be rectangular, here would be polar. How do I know the difference? Polar has r and theta, rectangular has x and y. All right, so there's a little bit of polar rectangular going on. All right, so let's express this in complex form. All right, well, I mean in polar form. Right now I know it's in rectangular because I have an x value and a y value. Right, I don't see any r's and thetas anywhere. Right, it's not some r times cosine sine. Right, that'll be the giveaway. It'll be some number parentheses. Right, otherwise they're all numbers. So I know my x is just 1. I know my y is just -4. Well, how do I find the r? Remember, r is just the term. R is the hypotenuse. These are the sides. So it's 1 squared plus -4 squared, all right, which equals rad 17. Well, I know my r, my theta, inverse tan, -4 divided by 1. All right, so inverse tan, -4 divided by 1. This is -75.96 degrees. So now we need to check. Go to your original, positive x, negative y. Right, positive direction, negative down. This is fourth quadrant. -75.96. Fourth quadrant. All right, so if I want to write it in polar form, it's r times cosine the angle, I sine the angle. So it's going to be r times cosine. You can change this into a positive if you want. It makes no difference. All right, we can distinguish between the two. Plus I sine. There you go. So this would be polar form. R cosine theta, I sine theta. All right. Well, again, just like everything, you can't just go from polar and not go back. So what if I'm given polar? All right. I'm given polar form. How would I change this into rectangular? And how would I graph this? Well, let's see first. I know the r is 2. I know the theta is pi6. Well, change this into degrees, unless you like radians. All right, there's no reason why you couldn't. So here's an r of 2. Here's a theta of 30. Can you graph r is 2, theta is 30? Sure. All right, go over 2. Here's my circle. My circle. I go 30 degrees. This is 1, this is 2. So I need a distance of 2. I'm facing. R is positive, so I step forward. That's r, 2, 30 degrees right there. All right. Well, how do I express it in rectangular form? Well, I need to do this now. So it's 2. I'm going to keep it in degrees. I sine 30. All right, let's distribute the 2. So to do rectangular, all I'm going to do is actually figure this out. All right, so now what is cosine 30? Well, cosine 30 is rad 3 over 2. All right, to sine 30 is a half. Right, I got those straight from the triangle. All right, 30 degrees, 60 degrees. All right, so the only triangles I know are 30, 60, 90, and 40, 40, 45, 90. Cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. All right, and now just do the math. Rad 3 plus I. All right, piece of cake.